Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to talk about Chapter 7. Chapter 7, Design and Implementation. Actually, there is nothing really new in this, for the design and implementation, except we are going through an example, a weather station. The only thing here we are going to cover, which is important in this one, and that's why we are going to cover the whole chapter in one video, in one lecture. Implementation issues like buy or build the system, reuse, what type of reuse, what's the history of reuse, and finally we are going to talk about the open source. When we talk about what real we're going to talk about here, and topics covered, object-oriented design using the UML, which it is through that example of the weather station, wilderness weather station. Implementation issues, as we just talked about a second ago, and open source development. Well, design and implementation, a software design implementation is the stage in the software engineering process at which an executable software system is developed, which it is after, the analysis, after we collect all the information, after we get the requirement, functional and non-functional, domain, all these requirements. Now we are going to the design. After we get the ERD, after we get all the logic, modeling, etc., we go into the design, we design the system, and then we write the system, we test it, whatever, all these things, it's design and implementation. Software design implementation activities are invariably interleaved. As we always say, in software engineering, most of the activity, those activities, adjacent phases or adjacent activities are interleaved, متداخلات من بعض من بعض. Why? Because while we design, we have something in mind how we're gonna implement it. When we go try to implement it, probably we'll find some defect. Something went wrong. So we have to go to the design, change the design, and then go to the implementation. So it is interleaved, متداخلات. They are kind of, let's say that, iterative, like a design, implementation, until we get it right. Software design is a creative activity. In the design, always it's a creativity. It is nothing really you could follow by like a menu or something. You could just read it from a manual or whatever it is. No, it is something creative. So you have to understand fully the environment around you, what are the requirements, and then you could choose what type of design really good for this requirement for that system, which you identify software component and their relationship. How is, what kind of component we have in the system, how you're going to segregate these components, what is the relationship between these. Of course, it's based on the customer requirement. Software implementation is the process of realizing a design as a program, which it is we're moving on and to the implementation, and we take the requirement, we take all these design, the one it come up with the function, component, whatever, and we write the programs for. Well, as we said, what's really our option here? Are we going to build, after we find out all the requirement, all the information really we need, all the issues from the customer, sometimes financially, sometimes probably they need them fast, the system or whatever. After we understand fully the environment around that system, probably we could come up with a decision. Are we gonna buy it or build it? Even if we're gonna buy it, is the technology there in the market? Is there a system already built in the market? So all these kinds of questions we have to ask ourselves, answer them, and then we could choose the best choice. Either we buy it or build it. In a wide range of domains, it is now possible to buy off the shelf. That's why we call it commercial off the shelf, COTS, COTS, that can be adapted and tailored to the user requirement. For example, if you want to implement a medical record system, you can buy a package that is already used in hospital. It can be cheaper and faster to use this approach rather than developing a system from scratch. When you develop an application in this way, the design process becomes concerned with how to use the configuration feature of that system to deliver the system requirement. What do you mean by here? I mean, when you buy something already been designed, so I believe you have to fit your requirement and that design. Because for sure, it's not going to be designed the way you do it like 100%. So it is compatible, but not really fully compatible system. It is tough really to apply a system from the market to your business without any tailoring, without any changes, modification or whatever. Now it depends. If the changes to the system, it is a lot, so don't buy it. So in general, in the industry, we talk about, if the system cover 75% of your requirement and more, I think it is a good system to buy. If it is less than that, don't do it. An object-oriented design process, a structured object-oriented design process involves developing a number of different system models, many different models. They required a lot of effort for development and maintenance of these models. And for a small system, this may not be cost effective. For a small system, I think you don't need really to put that much effort in doing this. However, for a large system developed by different groups in many different areas, design models are an important communication mechanism. Well, object-oriented design process stages. Again, we go, to chapter 5 and chapter 6, the way we covered it before, what type or what activity, what kind of model we are going really to create, There are a variety of different object-oriented design process that depends on the organization using the process. But there are common activities. Activities you have to do no matter what. We define the context, the boundary, context diagram, the system boundary, and the environment around it. We design the system architecture, which is architecture design. Identify the principal system object, the classes, which it is the structural one. We develop a design model, and we specify object interfaces. What is the models? What the interface between these? Example here, process illustrated here using a design for wilderness weather station. First of all, we have to look at the context. Understanding the relationship between the software that's being designed and its external environment. So we have to find out what really the system has to do. What's the boundary of it, which it is the context diagram. How to provide the required system functionality. How to structure the system to communicate with each environment, which it is we have to have what really we're gonna do to define the context, the boundary, and then the external entities around it. Understand the context also lets you establish the boundaries of the system. Setting the system boundaries help you decide what features are implemented in the system being designed and what features are in other associated systems. So we could divide, this component or feature of the system. We could really use a feature from other system, but we put it in the boundary. It becomes like a stakeholder, but it is not a person, but it is really another system in that environment. Well, we create here too a system context model is a structural model that demonstrates the other system in the environment of the system is being, which is the context model, context diagram. The one we talk about the interaction model, which is dynamic, which it is a use case and interface design, as we talk about it in the chapters, the previous chapters. If we look at the weather station, and we could find out, what in the context of it, what's those subsystem of that one. First of all, we need a control system to control the satellite and the weather station function, the communication between them. We need the weather station itself. We need weather information system, the information which it comes from the satellite, and we need the satellite which it is get the information from the instrument in the wilderness. So these four type system and then we set up the relation between them. It's like when you look at the control system and the weather information, the relation is 1-to-1. But control system and the weather station, because we could have many different weather stations in the wilderness, it has a relation, it's 1-to-many. And the same for the satellite and the control system, etc. Then we go to find out, what functionality we are going to do. What functionality can be done by some of the actors. What actors we have? We have actor here like a weather station system. We have a control system. They work here as an actor. Control system, as an example, is doing a restart for the station. It go and do a shutdown, reconfigure if we're gonna add a new instrument to it or whatever. Power save, to put it like an save and power, when we have less power, and remote control. Weather station information, report weather and report status. So really these are like use cases for those actors. Well, if we look at the description of these use cases, first of all, the use case report weather, the actors weather station and weather station system and weather information system and weather station. Description, the weather station send a summary of the weather data that has been collected from the instrument of the collection period. In the collection period to the weather information, the data sent are maximum, minimum, and average ground and air temperature, maximum, minimum, and average, and on. So it's explanation and description what the information it's been sent by the instrument to the weather station, which it is the weather information system. The stimulus, the weather information system establish a satellite communication. What's the stimulus here? What is the event? We establish, a satellite communication with them. And we do the request. A response, summarize data that comes from that instrument, go to the edge to send to the weather information system. Command weather station is usually asked to report once. This is an example, we went through it in the previous chapters, but I mean, if you when you want to do your program, when you do your project, I think you have to follow this. When you have a use case, you have to do some kind of description for it here in order to show the actor, in order to show what really the use case, what's the description of it, what is the event, what is the response, and if there is any comment. Well, right away we'll go to the architecture design for this. Once interaction between the system, what we build the interaction through the use cases, and we know what really how they interact with each other, the component of the system, and all this environment has been understood, you use this information for designing the system architecture. You identify the major component that make up the system and their interaction. We know the interaction, what are the major component, all these, after we put it in the context diagram, we explode it to the component and the relation itself through the interface design, and now we have to put it in an architecture. And then we organize the component using an architecture pattern such as layered or client server or whatever we see. The weather station is composed of independent subsystems that communicate by broadcasting messages on a common infrastructure. So if you look at it this way, you'll find, well, since they are going through the satellite, probably we need a net. Probably the design here is going to be like a client server. We'll see. Well, if we look at this high-level architecture, we'll see, the subsystem of the weather station. We have a subsystem, like fault manager, configuration manager, power. And then on the other side, we see a data collection, communication, instrument. And there is a communication link between. So the communication link is, which it is really like the internet, or satellite, through satellite or whatever. And then we'll go down to one of these subsystems, which is the data collection. Data collection, it has some component. It has like a receiver, which it is receive the command or the order from the weather station to what really they want to get from the weather data from the instrument. The weather data itself would get it, and then the transmitter, which transmit the information, which it is the collected from this instrument to the weather information system in the headquarters. Well, actually, how really we identify the object? Well, there is no magic formula, as we're saying here. I think you need to understand, fully probably the system, the requirement, the business rules there. Sometimes we say it's easy. It's easy to really to get some object. You walk into the environment, like if you want to go to like university, and what really kind of object, how we really identify the objects in university system. You go there and you walk in and you start really looking around you and you see object, something. What's that? You see somebody there. You say, oh, this is a student. What's the student doing? Doing so and so and so. What's that? This is faculty member. What's this? This is a lab. What's this? This is a lecture room. Those are the object. So you have to go to the environment and try to figure out the object from the environment itself. Identifying object classes often difficult part or object of object-oriented design. There is no magic formula for object identification. It relies on the skill, experience, and domain knowledge. That's why I said we have to understand fully, that you have to have the knowledge about the domain, business rules, what's going on in that system. Object identification is an iterative process. You cannot get it from the first time. You have to do it again and again and again in order to get it the right. Well, if we look at, the weather station, we walk into the weather station and we said, what's that? We said, well, this is weather station. What's that thing? Oh, it's a weather data. What is this? This is parameter. What's this? This is anemometer. What's that? It's a ground thermometer. So each one of these, it's an object. What it's doing, we'll take the ground thermometer. What it has, identification number to it, and then a temperature. These are really the attribute to it. And what function they do, a get and test, which it is the thermometer, درجة الحرارة, درجة حرارة السطح, whatever. Anemometer, سرعة الريح. Again, that's an object. It has 3 attribute, the number, identification number or whatever, wind speed and wind direction. Again, attribute or the functionality, get and test. The same for the parameter. Weather data, the same. It has air temperature, ground temperature, wind, etc., etc., and the function are collect and summarize. Then we continue with design model. Design model show the object and object classes and relationship between these entities. There are static model, describe the static structure of the system in terms of object classes and relationship. Those are the static one, as we said previously in those chapters. The static one is like the class diagram. We have this object, this object, this object. There is a relation between this and that one, but we don't know what kind of relation it. And the dynamic model would describe the dynamic interaction between these objects, as we are going to see shortly. Well, here we give you some example of the design model. What kind of model we are going to do actually, which it is the same. Actually, I put it in the video of the project description video, and the one we cover it, in the previous chapters. Subsystem model that show logical grouping of object into a coherent subsystem. Subsystem, as we did just a few slides ago for the weather station. Sequence model, which it is an interface thing. They show the sequence of object interaction, the relation between this object and that object and that object, and what kind of input, what's the output, etc. And we cover this one back again in chapter 5. A state machine, the logic of each individual object. We'll go to the logic of it, if then else. And finally, or other models, probably we use case model, aggregation, generalization, etc. All these models really we need. By this we cover, the example of the weather station, and now we go to the reuse and we see some information about it. Well, implementation issues for any system, for any project, it's not really here the focus and not in the programming or whatever. There are some, things which it is like a reuse. Are we going, to build it from scratch, or we could really reuse it, probably the whole system or part of it. Configuration management. During the development process, you have to keep track of the many different versions of each software component in configuration management system. Like the version, how many the programs, the version 1, 2, 3, etc. That is, when in the development process and again in the maintenance process. Host target development, production software does not usually execute in the same computer. If we gonna execute some of our system in a different platform. Those, some issues I think we should consider in the implementation. Well, the reuse from back in the 60s, when we start programming language, in the 60s to the 90s, probably to the late 80s, whatever, most new software was developed from scratch. By writing all the code starting from scratch in a high level programming language. Start from COBOL, PL1, Fortran, C, C++, etc. The only significant reuse that time, it is using like a subroutine, function, or object later on, in the object-oriented programming. Cost and schedule pressure mean that this approach become increasingly inviable. Because of the cost and because of the pressure and to finish the system fast and quick, it's become really this option. It is not really doable. It is not really, it doesn't worth it, do it. If there is another option, which it is reuse an existing system, buy it from the market if it is like commercial of the shelf, or buy it, from a company like an ERP, enterprise resource planning, whatever, especially for commercial and internet-based system. The reuse is always usually for the common system. The reuse, if you talk about the payroll system, it is the same as in most companies, institution, whatever. The requirement very, very close to the same. Any company or any institution or any individual who are going to design a payroll system, the payroll system usually has the employee number, ID, whatever it is, how much the base salary, how much the extras, if there is any extra warrant, how much the deduction, and then the net of his salary, whatever. So because it is common, probably this is the first system has been put in commercial of the shelf. They pack it and they sell it for everybody. And here we talk about the reuse here. An approach to development based around the reuse of existing software emerged and is now generally used for business and scientific software. Reuse actually it comes in many different levels. We use an idea sometimes, an abstract level. At this level, you don't reuse software directly, but you use a knowledge of a successful abstraction in the design of your software. So you could really, use an idea of a system, an abstract thing, whatever. An object level, at this level, you directly reuse object. You just get an object and you inherit that object from a library rather than writing the code itself. And this is the same, this is the way really we used to do it before, like writing it like a subroutine or a function, put it in a library, and just whenever you need it, if that code, if that piece of logic, it's needed by many different programs, so we don't have to write it in each program. So the program, just get it from the library. Component level, component are collection of objects. Probably we could really get just a component or a subsystem. Just subsystem or the system, a whole system, we could really buy it as in ERP. We'll take like a university system. The whole university system, we'll take it from there. Or component, we could buy probably the registration system. But in this case, we have to have the system, or the system has to be compatible with the other component in that system. Well, what's the cost here? The cost of the time spent in looking for software reuse and assessing whether or not. Well, we say sometimes cheaper, but actually it is not cheaper. But in the long run, it is cheaper. Reuse, which it is, we consider it as like outsourcing, because reuse, it's really outsourced. We're gonna use it from a different source outside our cycle here. So the time here, we have to spend two things. Or one thing, important thing, is we need to find out what our customer want, collect requirement, and then we are going to see the technology outside, or the program, or the thing we are going to use to find out what really that system has. So the time spent in looking for software to reuse by assessing whether or not it meets our needs. Where applicable, the cost of buying the reusable software, you have to pay. You have to pay, first of all, which is the cost of it, and to find out if really that's the thing really exists in the market, that's what really we want. Then buying it, the cost of it, for large off-the-shelf system, the cost can be very high. Why? Because when they sell you something like this, they don't sell you just one time only. They sell you for a lifetime, like the ERP. You take it and you pay really high price for the first time. But guess what? Next year or the year after, when they have a new release, you will take it almost free, except just for a percentage of fees, like 5% or 10% or less than that. So in this case, after 50 years from now, your company always have the latest technology, and you don't need any modification to the system. The cost of adapting and configuring, if that object or that software, the one we're gonna reuse it, it's not gonna work fully with our system. I think we need to adapt it to make it compatible to our system, changing something from there and there. The cost of integrating reusable software element with each other, which is the compatibility, as I just said a second ago. Well, what left from this chapter is the last 4 slides. We're talking about the open source development. We need to understand what really open source in general, and the licensing really you need to have, and what is really the whole concept. Open source development is an approach to software development in which the source code of a software system is published and volunteers are invited to participate in the development. This means you write your program and you put it in the system, and it is free for everyone. Like Linux. Linux, it is a version of Unix. Unix, the American version, and Linux is the European. Linux is free, but Unix, the operating system, you have to pay for it. Its roots are in the Free Software Foundation, FSF, which advocates support the source code they support, and they saying their idea, the source code should not be proprietary, but rather should always be available for use to examine and modify as they wish. Then it is not really property, it is not your own. You write it, you put it there, and it is free for everybody to take it, to change something to it, whatever it is. Open source software extends this idea by using the internet to recruit much larger population to volunteer. So they use the internet to contact a lot of people to participate in this effort. Open source system, as we just mentioned now, the best known open source is Linux. Linux operating system, which is widely used as a server system and increasingly as a desktop environment. Other important open source like a Java, Apache web server, MySQL database management system, and etc. I think you should ask yourself, in this kind of issue, should the product that is being developed make use of open source component? Should an open source approach be used for the software development? Well, it depends on these, answers, you could really try to find out if really your approach is really good to use the open source. Well, there are more and more product companies are using an open source approach. Their business model is not reliant on selling software product, but on selling support for the product. So the business, their business, it's not really selling the source code, but the support for that product. They believe that involving the open source community will allow software to be developed cheaper, quickly, and will create community of users for that software. Which it is by creating that community, well, I think, you get more knowledge and understanding about that system. Of course, using the open source, it's not really just that easy. I think you have to have some license to it. A fundamental principle of open source development is that source code should be freely available. This does not mean that anyone can do as they wish with that code. Legally, the developer of the code, either a company or individual, still owns the code, still your code. They can place restriction on how it is used by including legally binding condition. So they could put some really constraint on that one and some restriction that if you want to use it, you could use it for so and so, whatever. Some open source developers believe that if an open source component is used to develop a new system, then that system should also be open source. Others are willing to allow their code to be used without this restriction. Well, it depends, on the person or on the institution who developed that one. The developed system may be proprietary and sold as a closed source. Probably you could really have this one and you could sell it as a closed source system. You could change your mind and you could sell it as independent. Well, what are the key points, for the whole chapter? The chapter is really very small. Most of it covers, the wilderness weather station, the steps we went through, from defining what really the object, the relation between them, how we make the context diagram, explode it to its function, and then the relation, the interactive between these function, which it is, we cover most of the previous models and patterns of design we talk about in chapter 5 and 6. When developing software, you should always consider the possibility of reusing existing software. The issues, the first time when you want to develop it, I think you have to look around to see if somebody did it before and it is available for you. Configuring and configuration management is the process of managing changes to evolve a software system. It is essential when a team of people are cooperating to develop a software. We have to configuration management in order to do the change. When the system, the evolution of the system, you have to have configuration management to do that. Most software development is host target development. You use an IDE, integrated development environment, and a host machine to develop the software, which is transferred to a target machine for execution. Open source development involves making the source code of system publicly available. This means that many people can propose a change and improve the software, and they could use it freely. By this, we finish that chapter. As we said, most of it as an example, which it's really, you could use that example and the knowledge from this to how really you're gonna do your project. And then the reuse and the open source and some issues are the important things in this chapter. So we are done for now. Thank you and see you later.